Good morning. We are going to first review parallel lines and then get into perpendicular lines, which hopefully we reviewed right in class or learned what perpendicular slopes look like. Reminder that parallel lines have the same slope. So if one line has a slope of 4, another line has to have a slope that is also 4. But a perpendicular slope to 4, perpendicular means our slopes are opposite reciprocals, meaning if one is positive, the other is negative, and then reciprocal meaning our fraction would have to be flipped. So if this slope is 4, a perpendicular slope, instead of being positive, this one would have to be negative, and instead of being 4 over 1, I just made this a fraction. If it's not a fraction, just put a 1 under it. 4 divided by 1 is still 4. But to take the reciprocal, we'll have to flip our fraction, so it would be negative 1 over 4. Those slopes would be perpendicular. Next, we have negative 2/5. So parallel slope would have to be the same, also negative 2/5. But a perpendicular slope, we're going to have to flip our fraction. Instead of a negative, it has to be positive. Instead of 2 over 5, it would have to be 5 over 2. Next, if one slope is negative 6, the other is also negative 6. And then to take the opposite reciprocal to get a line that's perpendicular, instead of negative, we'd have to have a positive. You don't need to put a plus there, but just in case you want to remember. And then reciprocal of 6 over 1, well, flip that would be 1 over 6. If this one has a slope of 7 over 2, the other slope for a parallel line also has to be 7 over 2. But for a perpendicular slope, instead of positive, this one would have to be negative. That's the opposite part. And then the reciprocal would be, instead of 7 over 2, we want 2 over 7. This next one, 1/4, parallel to that would also be 1/4. But perpendicular, instead of positive, we'd want negative. Instead of 1 over 4, we'd want 4 over 1. Now 4 divided by 1 is the same as just negative 4, so either of these would work. Next we have 0.75. Well, this is, if you read this, 75 hundredths. So you could put this as a fraction, 75 over 100, and simplify. Some of you might know that 0.75, thinking of quarters, this would be 3 out of 4 total quarters in a dollar. That would just be dividing by 25. All I did was simplify that fraction. So that would be 3 over 4. If you didn't know that, that's okay. We can't take the reciprocal of a decimal. That's why we had to convert it to a fraction. So if this one has a slope of 3/4, this one also has a slope of 3/4. And then to get the perpendicular slope, instead of positive, it'd have to be negative. Instead of 3 over 4, it would be 4 over 3. So let's go ahead and graph two lines that are going to be perpendicular. It says perpendicular lines, if we read this here, have slopes that are opposite signs, so one's positive and one's negative, and reciprocals, meaning we will flip our fraction. So in order to graph, we have to solve for y. So I'm going to move this to get y by itself. So the opposite of subtracting 6x would be adding 6x. So those eliminate. 6 minus 6 is 0. So we get y equals, and then write your x's first, 6x minus 1. So in the form y equals mx plus b, that was our goal. We got y by itself. M is 6, or as a fraction, 6 over 1. And then b is negative 1 on the end there. This second one we also need to solve for y as well so we can graph it. However, you can tell what the slope is because this is technically in point slope form. You know the slope is going to be negative 1/6, but we need to solve it anyways. So I'm going to distribute or draw my box. We have a negative 1/6 and then x plus 6. So negative 1/6 times x is still negative 1 over 6x. Negative 1 over 6 times 6. 6 is really just 6 over 1. So negative 1 times 6 is negative 6. 6 times 1 is 6. 6 divided by 6 is 1. 6 goes into 6 one time, and so it's just a negative 1. And that's easy to think about, because if you think about a pie, for example, and you have 1 out of 6 pieces 6 times, well, there's 1 time, 2, 3, 4, 5, 6. That would be 1 whole. So that makes sense. So we have y minus 2 equal to negative 1 over 6x minus 1. And then we need y by itself, so the opposite of subtracting would be adding 2. Those eliminate, and we get y equals negative 1/6 x. A negative 1, but plus 2, there's more positives. 2 minus 1 is 1. So b is 1, and my slope is negative 1 over 6x. So I'm going to graph this. This one begins at negative 1, and my slope is rise 6, and over 1, positive 1 is to the right. So up 1, 2, 3, 4, 5, 6, and over 1. Or down 1, 2, 3, 4, 5, 6, and over 1. So there's our first line. And you can tell right away that these are going to be perpendicular because this has a positive slope, this has a negative slope, and 6 over 1, 1 over 6, they are opposite reciprocals. So this one begin at 1, positive 1, and my slope is negative 1 or down 1, 6 to the right. Down 1 and 1, 2, 3, 4, 5, 6 to the right. Instead of going down and right, we can also go up 1 and 6 to the left. So those look like perpendicular lines. If you're not sure, take the corner of a piece of paper and put it right in here to see if that looks like it fits a 90-degree angle. So those are our two lines. And then it says, how do you know if two lines are perpendicular? Well, in order to be perpendicular, we're looking at M. Our slopes have to be opposite, meaning one negative and one positive, and the second word is reciprocals, meaning our fraction is flipped. These are two words. It looks like one big word there. Opposite, reciprocals. Again, that means one's positive, one's negative, and this one means your fraction is flipped. Let's try one more like that. Flip over the back side. We need to solve for y, so this one, all we have to do is move that plus 3 by subtracting 3. So we have y equals, write your x's first, 2 over 3x, and then minus 3. So m in the form y equals mx plus b, m is 2 over 3, and b right there is a negative 3. Let's solve this second one as well. This one just has a 4 here. I need to get rid of that 4, so I'm going to divide everything by 4. So those eliminate, and we have y equals, well, I have negative 6 over 4. I can simplify that by dividing by 2. And that will give us 6 divided by 2 is 3, so negative 3. 4 divided by 2 is 2, so we have negative 3 over 2x. Plus 8 divided by 4, that's just a nice whole number of 2. So there's our answer. We have y by itself, and we simplified our fractions. So we have m is negative 3 over 2, and b is 2. So I'm going to graph both of these. I'm going to begin first with this one. Negative 3 means we're going down 1, 2, 3. So we're beginning. And our slope is rise over run. Rise 2, run 3. So up 1, 2, and over 1, 2, 3. Again, up 2 and over 1, 2, 3. Or the opposite of up and right would be down 2 and left 3. So there's the first line, but now we need to graph the second one. This second one begins, B is 2, up 1, 2. And my slope is negative 3 or down 3, 2 to the right. So down 1, 2, 3, 2 to the right. Down 1, 2, 3, 2 to the right. Or up 3, 2 to the left. If you're not sure if you did this correctly, again, take a piece of paper, put the corner in here to see if it makes a 90-degree angle. And then last same question, how do you know if two lines are perpendicular? The slopes have to be or are opposite and reciprocals, meaning one's positive and one's negative, and our fractions are flipped, which we can see here. This one's positive, this one's negative, and then reciprocals, meaning 2 over 3 and 3 over 2. Alright, last page here. It says write an equation of the line that is perpendicular to the line given. So remember, perpendicular means our slopes have to be opposite and reciprocals. So here's our first equation. This one's already solved for y for us. It's in the form y equals mx plus b. So I know m right here is negative 2 over 7. But there's no b, so I can assume it's 0. So the only thing I know down here in line B is that these slopes are perpendicular, meaning instead of having a negative slope, this one has to be positive. And instead of having 2 over 7, we need the reciprocal, or 7 over 2. So we can write a new equation using our point, x1 and y1, and our slope. Since we have a point and a slope, it makes sense to start with point-slope form, just like what we did with parallel lines. So I'm going to plug in what I know, y minus y1, which is right here, negative 4. Those two negatives make a positive. Then m is our new slope here, 7 over 2. And then in parentheses, x minus x1, which is negative 2. Those two negatives make a positive. So we have to distribute to get y by itself, so we can graph this. So I'm going to draw my box. I have 7 over 2, and then x plus 2. So I know 7 over 2 times x, just put them together, 7 over 2x. And then 7 over 2 times 2, 2 is just 2 over 1, so 7 times 2 is 14, 2 times 1 is 2, while 14 divided by 2 is 7. So we have y plus 4 equal to 7 over 2x plus 7. Now our goal, we're trying to get y all by itself, so that's why we distributed to get rid of our parentheses. We need the form y equals mx plus b. So we need to get rid of this 4 now. So the opposite of adding 4 would be subtracting 4. So those eliminate, and we have y equals 7 over 2x, and then 7 minus 4 is 3. So now we know b on the end here is 3. So let's graph both of these. I'm going to graph this top one, which would begin at 0, because b is 0. And my slope is negative 2, or down 2, and 7 to the right. So from here, down 2, 1, 2, and 1, 2, 3, 4, 5, 6, 7 to the right. Or up 2 and 7 to the left. So there's the first line, line 1, or line A. We graph that one. Now line B begins at 3. So from the origin, up 1, 2, 3. And our slope is rise 7 and 2 to the right. Well, I can't go up 7, so instead of going up and right, I have to go down and left. So down 7, 1, 2, 3, 4, 5, 6, 7, and 2 to the left. Those are the only two dots I can plot. So put your line through those, and we are done. Those are our two lines that are perpendicular. Let's do the second one. It says line A is y minus 5 equals 1/2, and then x minus 8. So first we just need the slope. We just need to write an equation that is perpendicular to the one they give us. We don't need to graph this one. So that's why we don't need to find B. This one happens to be in point slope form already. So we know M, our slope right here, is just 1/2. So reminder, we're looking for a perpendicular line. So instead of a positive, we have to have the opposite to have a negative slope. And the reciprocal, instead of 1/2, we would want 2/1. So 2 divided by 1 is really just -2. So if you want to just use -2 instead of 2/1, that's fine. It's the same thing. We also have this point, x1, y1. And we have a point and a slope, so I'm going to start off with point slope form. Oops, forgot the equal sign. Y minus y1 equals m, and then x minus x1. So let's plug in what we know. Y minus y1 right here, which is 10, equal to m, which is just a -2, and then x minus x1, which is 7. So I'm going to solve this for y. So get rid of your parentheses first. I'm going to distribute -2, x minus 7. So -2 times x is -2x. A negative times a negative makes a positive, and 2 times 7 is 14. So over here we have y minus 10, and then -2x plus 14. And then get rid of y, we need to add 10. The opposite of subtract was add, so we have y equals -2x. And then adding these up, we get a 24. So this is why we didn't graph this one, because we would have to begin at 24, which is so high on our y-axis. So there's our equation of the line that is perpendicular to the line that they gave us. So we have one in-class activity, which is to determine which of these lines are parallel and perpendicular, and then a worksheet, which is your homework. The front is just graphing two lines. The back is just like we did on the back side. This last question, you need to find the slope of each of the four lines by just counting rise over run, and then tell me at the bottom, oopsies, which ones are parallel and which ones are perpendicular.